of lines and linear equations. So we have a couple of different forms of a line. We have first, don't be alarmed. Oh, come here. Again, as I stated earlier, just relax. Pay attention. We have slope-intercept form, which we're familiar with, where we have our slope here and then our y-intercept. So if I wanted to graph this, I'd first graph using the y-intercept, which is the point 0, comma b, okay, where 0 on the x-axis and then up or down to whatever this is. And then from there, I use the slope to find the next point. I go ahead and connect those dots. So using rise over run. Using standard form, right, we graph using intercepts. That was what we said was our trusty cover-up method, where I plug in 0 for the x, I solve for the y. Plug in 0 for the y, solve for the x. I have my 2 points. I can go ahead and graph the equation of my line. The next one, right, we had was point slope form. Point slope form. Ooh, scary skeleton. Right? Our point slope form, we have our slope here, and then a point where the x coordinate is there and the y coordinate of the point is there. So let's go ahead and write the equation of a line in slope-intercept form through the point 43, and that has a slope of 2. So let's go ahead and start with this point slope form. I don't have the slope, the intercept, right? I don't have b. But I can easily go ahead and put it in point slope form and then figure out what the slope intercept form is. So this is always handy. And oftentimes in geometry, I'm just going to leave it in point slope form. So in this case, I have my x, y. So y minus 3 equals, there's the slope, 2x minus 4. So here, put it in slope intercept form, I'm going to solve for y. I'm going to distribute that. And then I need to go ahead and move that 3 over. So y equals 2x minus 5. All right. So there's our point slope form. And there's my slope intercept form. I could put it in standard form. I'm not going to do that right here. Oh my God. Write the equation of the line in slope intercept form for these. So let's see. Let's start with point slope form. Y minus a negative 8 is y plus 8. 1/2 x minus a negative 2 is x plus 2. Notice in here and here, it's just the opposite of whatever the point we have. Now I put it in slope intercept form. Y plus 8 equals 1/2 x plus 1 as I distribute through. Subtract 8 from both sides. Y equals 1/2 x. Yeah, slope intercept. I have a slope of, so now y plus 1 equals 5 times x plus 2. And again, simplify, distribute. Y plus 1 equals 5x plus 10. Subtract 1 from both sides. Y equals 5x. Now, I'm given 2 points. I don't have the slope yet. We have a formula for slope, though, right? And this is how I deal with slope. I know that the formula is y2 minus y1 over x2 minus x1. I don't really deal with it like that, because I'm pretty good at that. I remember it just like this. And I just remember y's go on top of their own x's for slope. Y on top of its own x. So I have x and y there, x and y there. So y on top of its own x, y on top of its own x. Let me just clean it up a little bit for slope. Clean it up a little bit. So 2 negatives together, that's a plus 9. And then 3 minus 2 is just 1, right? So there's my slope. Does it matter which point I use? Put it in point slope form? No, right? So I'll just use this first one because it's the first one. Why not? I'll end up getting the same equation line regardless of which point I hit. So y minus 5 equals 9 times x minus 3. Distribute y minus 5 equals 9x minus 27. And I'm going to add 5 to y equals 9x minus. Not too bad, right? Finding the equation of lines, getting 2 points, given the point and the y-intercept. All right, let's see what's next. Ah, let's do that one. That was right. 1. Wow. 1. Other way. There we go. All right, let's try this one more time. Then we'll do some of our notes from our actual packet. Hopefully this is all reviewed from 8th grade, 9th grade, and again in 10th grade. We've seen this many times before. So again, let's go fairly quickly. What do I remember? Y is on top of their own axis. So 9, 3, 4, negative 2. Does it matter which one I make the first point and the second one? No, we find the same slope either way. So 9 minus 5, or 9 minus 4 is 5. 2 negatives. 5 over 5, I have a slope of 1. And then I'll pick out one of these points, and I'll use negative 2 or 4. So y minus 4 equals 1x plus 2. So that 1 doesn't change anything, so I'm just going to add the 4 over. Y equals x plus 6. All right. So a real easy way to find the equation of y is given 2 points or point and the y-intercept. So into our note packets now. Into our note packets 3-7. Take a second. Use that idea of slope that I showed you to find the slope of the lines of the line that goes through these points. All right, let's see how we did on this one. All right, so let's go ahead and find the slope. So I'm going to put y's on top of their own x's. So I get 6 and 0 here. And then 2 and 5 here. 6 minus 2 is 4 over negative 5. So there is. Let's look. Can anyone tell me the y-intercept without doing any calculations? We found the slope. Can anyone tell me the y-intercept without doing any calculations?
Isn't it 6?
It's 6. How do you know?
Because 0 over x is 0.
X is 0, 1, 2, 3, 4, 5, 6. So the y-intercept has to be 6. So if I wanted to write the equation this line real easy, right? Minus 4 fifths x plus 6. There's the equation of the line, right? So whenever you have this 0 here, you know that the y-coordinate is our y-intercept. Remember, part of our goal this year in reviewing algebra is to make us much more efficient at it, to be able to recognize them. All right. Next, write the equations of the following lines in graph. So, come up with the equations of the lines and graph them. You can use point slope form. You can put them in slope intercept form. We'll look at a couple of different ways to handle these. So take a second, see if you can do these. I'll run around and help if anyone's stuck. All right, so maybe you guys attack this in different ways, right? So let me show you a couple of different ways to go ahead and look at finding the equation of the line. I saw some of you using a pretty dang smart method, if you ask me. Hold on, let me see if I can get a better one. There we go. So I saw some of you go ahead and graph this the following way. We have the point 2, 3 right there, and then we use up 5 over 1, but that's equivalent of going down 1, 2, 3, 4, 5, and over 1, and down another 1, 2, 3, 4, 5, and over 1. So there is, kind of missed that point right there. Well, there's our line graph, and you saw that the y-intercept was -7. So the equation of our line, y equals 5x minus 7. Okay? One way to attack that is by graphing it using point slope, finding out where it crosses the y-axis. A completely good way. Another way to attack this, we looked at point slope, right? But can I use slope intercept form to go ahead and find the equation of the line? Sure. Remember, in slope intercept form, I need two things. I need the slope, which I've been given right here. And then I need the y-intercept, that b. X and y just represents points on the line. So I have an x and y right here. So what I can do is go ahead and plug everything we need in. We have for y, m, and x, and then solve for b. So I have y is 3 equals m is 5 times x is 2 plus b, and I can solve for b. So instead of using point slope, I'm using that idea of slope intercept form to solve for b. So I get 3 equals 10 plus b. B equals -7. So now I have m is 5. So y equals 5x minus 7. So find the equation of our line graphic. We already looked at point slope form. Now that's how to use slope intercept form to find the equation of the line. Yeah.
Isn't the second letter, or not letter, number in the equation, like the 7, isn't it the y-intercept?
Yeah, -7 is the y-intercept.
But the y-intercept on your graph goes somewhere else.
Now the y-intercept is -7, all the way down here. Right? So the y-axis right there. All right, let's try this next one. Through -2, 6 with a slope of -5, 2. All right, so let's go ahead and find the equation of the line using point slope form this time. So I have y minus 6 equals -5 over 2 times x minus a -2 is plus 2. Now I'm going to go ahead and distribute. So I have y minus 6 equals -5 over 2x. And then remember how we deal with multiplying fractions. Negative times a positive is going to be negative. So I need to figure out what 5 over 2 times 2 over 1 is. Those will cancel. And I'm left with just 5. Then I'm going to add 6 to both sides. I get y equals -5 over 2 x plus 1. There's the equation of my line. And I'm going to use slope-intercept form to graph. I have my y-intercept here, is 1. And now what I'm going to do is go down 5 over 2. There's the next point. And I can graph my line. One thing I always go back and do is I make sure I didn't go the opposite way, right? If this is a negative slope, I know it's going to go down from left to right. If we have a positive slope, like the first one over here in A, we're going up from left to right. All right. There we go. All right, moving down. I'm going to go ahead and steal this coordinate plane here. And we want to know the equation of the horizontal and vertical lines through the point 2, 4. So I want to know the equation of this blue line and the equation of this red line. So first, I think it's important to have a discussion about slope. Let's remember our equation for slope. Right? We have y's on top of their own x's. Or we also said the change in y over the change in x. Another way to look at slope. Huh? So, dealing with zeros and fractions. Zeros on the top of a fraction. 0 divided by anything is what? 0, right? So if 0 is on top of anything, right? If this change in y is 0, over whatever is on the bottom, we know that's going to equal 0. So in this case, this blue line, this horizontal line, does y change at all? Does this go up and down at all? No. So this one, horizontal lines always have a slope of 0. And therefore, the equation of the line goes like this. Do I have a y-intercept right here? Sure. So let's see what happens when I plug in a slope of 0 and a y-intercept of 4. So I end up with y equals 0 times x plus 4. 0 times anything is what? 0. So we just get y equals 4. So the equation of a horizontal line is going to be y equals whatever that number, it goes to the y-axis. Another way to think of it is this. For all values of x, what does y equal? Let's go ahead and look at it. So if x is negative 5 here, what does y equal? 4. If x is negative 3, what does y equal? 4. If x is 0, what does y equal? 4. So on and so forth. So for all values of x, y equals 4. So all horizontal lines are y equals something. Can we have y equals a fraction? And it still being a horizontal line? Sure we can, right? Say we had y equals 1/2. That's just this horizontal line that goes through 1/2. What happens if we have 0 on the bottom of the fraction? Finley, what is 10 divided by 0? No, it's not 0. It's 10. It's not 10. 1. Undefined. Very good. Okay? When we have something 0, okay? Let's think about this. What if we had something very close to 0? Let's say I had 5 divided by something very, very small, 0.000000001. Is that going to be a large number? How many times 0.0000001 goes to 5? Yes, it goes up, right? It's going to be very big. So the smaller that denominator is, we hold the top constant, the larger that fraction is going to end up being. So 0 can't be divided into anything, and thus is undefined. So the slope of a vertical line is undefined. So I like to think of the slope of all, or the equation of all vertical lines as this. What does x equal for all values of y? So in this case, we can define our vertical line by what the x-intercept is. X equals 2. Right? So for all values of y, x equals 2. So if y is 2, x is 2. If y is 5, x is 2. If y is negative 3, x is 2. So the equation of a vertical line is x equals some number. So x equals 2.